Good morning. This is a recap of the Zoom lesson from September 16th, 2020. And what we did in Physics A was we tried to talk about position time graphs and how we can quickly identify velocity on them and what a related graph where we graph velocity versus time might look like. For most blocks, this seemed to be hard. As I popped in and out of breakout rooms, groups were struggling with this. So if you're not totally getting it after just class, hopefully this recording will help you if you want to review it some more, and we'll have some time to discuss it next time I see you as well. But let's take a look at what we learned today. I first showed some sketches of data that one of my old classes in Oklahoma generated. They had a thing called a motion detector, and it told you how far away from a wall you were. And notice I'm using D for position here because my old textbook did. Hopefully from this position time graph, you can see that someone was walking at constant speed. And we know this because the best fit line for position time, the black line, has a constant slope. And slope is velocity on a position time graph. So the fact that we have a constant slope here means that their velocity wasn't changing. That device also gave another graph where instead of bothering to plot position versus time, it just plotted the velocity as time passed. And there's a little more error in the data it generated, but the best fit line here is horizontal. And hopefully you could see that that's saying the same thing as the position time graph. Slope on a position time graph is velocity. This is a constant slope, constant velocity. Here on the velocity time graph, we have a constant velocity plotted directly. It's a horizontal line because the velocity is not changing. So those are saying the same thing in two different ways. And we need to get comfortable looking at one and being able to guess what the other one looks like. I had students look at this and I asked them to justify what I had written here. This graph on position versus time is decreasing slope, and that means this object would be getting slower. This object has an increasing slope, so that means this object would be getting faster. So we then talked about how would we generate the velocity time graph. So I showed students this graph here, and the specific functions here are not important. The fact this is a parabola, this is a line, had to do with this specific motion. But let's see how we could guess the velocity graph if we were just given the position graph. It starts out with a slope that's close to zero. It's essentially horizontal. So I have a low velocity. And that slope is getting steeper and steeper and steeper and steeper. And that means the velocity is increasing. So that means I'm starting with a low velocity and I'm increasing to higher velocities. So that's the kind of logic we want to use as we move back and forth between these graphs. So I gave people a worksheet that looked like this. And it essentially asked students, if you were given one graph, could you generate the other? And sometimes I gave you the position, sometimes I gave you the velocity. So I want to go through 1 and 2, which we did in class, and then I'd like to go through 6. So let's talk about 1 and 2. Basically, these are the same answers because the graphs have the same shape. They both have low velocity at the beginning because the slope is essentially horizontal or zero. And they both get steeper and steeper and steeper. So we should start with a low velocity close to zero that then increases. So here's what the answer looks like for that. As you can see, it's identical. Now, obviously these are not the same graph, but what that means is only the slope on the position time graph is important in creating the velocity graph. Low slope, high slope, that means we have an increasing graph. Now that leads to an issue when you have to go back in the other direction. If I had just given you this velocity graph, how could you tell whether this was the original graph or that one? You would have to be told what the initial position or the intercept is. And this is related to the discussion we had about displacement and position on the problem where you're wandering in the desert. Unless someone tells you where you start, you can't pick between these two graphs. So when you look at a question like number 6, I know that I start with a negative velocity and that negative velocity gets more and more and more. So I expect to have something that starts off with an initial negative slope, and then that gets steeper and steeper and steeper. But where I start it, what my intercept is, I just make that up. I don't know what it is. So let's look at the answer in number 6. So I started, actually this is not a good drawing here. I should have started maybe here with a negative initial slope, and it should have been getting more and more and more. So that lets me know that I've got an increasing negative velocity. So I should sketch that out for you guys. Give me a second to do that. So sorry, this is something for another class. So the actual answer to number 6 should have been something like this. So x t, it should have been initially with a negative slope and getting more and more and more negative. But of course not curving back. So something like that. All right, we'll have more time to talk about this in class. And I appreciate the work this morning. And I hope everyone has a great rest of their day.